Hi, I'm Devon Yeblonski from Mercury Systems. I'm a product manager in our sensor processing division. Mercury is a designer and manufacturer of embedded system products for military aerospace defense, like many others here. You may have seen we've been growing a lot lately. We have a lot of different capabilities. I work in the sensor and mission processing realm, which is kind of the legacy Mercury, the rugged embedded signal processing systems, real high performance, Intel x86, GPUs, FPGAs, that sort of thing. So I'm going to talk about artificial intelligence, sort of a trend in our environment for embedded tech trends. Luckily, everybody else today did all the details of kind of the content and the nitty-gritty behind it. So I'm going to kind of talk at a higher level about why companies like several of us here are important to this trend, what's different, what are the challenges, and what some of the commercial technologies that are out there outside of vendors like us aren't able to achieve that we need to focus on. So artificial intelligence is kind of redefining global power, or has the potential to. I think there's been a lot of press about China, Russia, other countries trying to challenge the US's air power and power in combat and on our home front. Visionaries like Elon Musk starting to talk about it. It could be a big deal. It's kind of the next generation that maybe we won't have the same advantages that we've had in the battlefield if we don't quickly invest in it. Actually, I was reading about in Beijing, they're building like a $2.2 billion US, 150-acre complex that's just for big data and artificial intelligence research. So from a national level, other countries are putting a lot of investment into this area. And you're starting to see the US also do the same, putting a lot of money out there to try to go after new capabilities and make sure that we're prepared for this next generation. So interestingly enough, as we go into this future of battling for this, having the best technology, I think the US does have some of the best technology in the commercial industry in terms of artificial intelligence. Most of the big companies you hear about, social media, the assistants, the financial industry, are using these artificial intelligence algorithms and building really great tools that you would think that would just lend itself to making us the best in all aspects in defense everywhere else. But their focus is really on a different area. They're focused on performance at a different scale. Like in this picture here, you're looking at a big data center where the sense of space and power and cooling, all of that is completely different than what we deal with in our environment. And even some of the attacks like security, we talked a lot about security today, it's maybe a different kind of attacker in some cases coming in looking for user data. When these systems are connected to the internet, there's different vectors of attack that adversaries can come after. So it doesn't necessarily translate over immediately to defense. So to me, when I look around, it seems like, from an algorithm perspective, from a hardware perspective, it's really a blue ocean for the defense industry in terms of there's funding available, there's companies out there trying to do this stuff, but there's so many applications and algorithms still to figure out how artificial intelligence can help. Is it maintenance? Is it tracking of objects? Is it health of people in the field? It's all sorts of things. So kind of mixing those two, right? We have the commercial industries that are doing really well with artificial intelligence. We have all this stuff that can be done in defense. Can't we just merge the two? If you've followed the news, there's a lot of funding around the Maven project and Google's involvement. And they were expecting hundreds of millions of dollars a year from the defense industry by creating object detection and things like that they can use from their algorithms in the commercial space and bring it to defense. Unfortunately, they've already been backing out of that project because it's not just a matter of whether your technology can translate, which in some cases it can. It's the people that work for your company might work for your company for certain reasons, and they came to work at a commercial search engine company and big data company, not working on something, whether it's for offensive or defensive purposes. They didn't intend to work for a military or defense company. And that's the problem they ran into that effectively backed them out of being able to work in this space and contribute their technology. On top of that, there's lack of secret classified personnel, facilities, understanding and know-how. I mean, all the data, every artificial intelligence industry has a problem with data right now. I mean, whether it's Tesla trying to make a self-driving car, or it's the defense industry trying to, detect bad guys. It's tough to get the data, but it's even more tough when the data is under very high classification level. It comes from different departments in the government and all needs to be combined. And you're a commercial company that has never really worked that closely in that kind of aspect with the government. And even if they had the facilities and the cleared people, they may not have the trust built up and understanding of working together in that kind of aspect. Which is where companies like Mercury and the rest, many of us in the room have capabilities and that trust level and experience working on these kind of applications for a radar processor, EOIR, or something like that, where it's a natural progression. So getting more into what's specific about the challenges in defense, that the Googles and the Facebooks may not be typically used to working with. It's the extended life the product has to live. We have to deploy something, it has to work for 10, 15 years. It just doesn't mean just work, it means you have to have replacement parts. It means you have to have support. It means you can't make a $200 million hardware mistake and just figure that next year you're getting the new batch from the next gen product anyway, and you're just gonna throw it, sell it all off on the third-party market. We don't have those liberties here. Size, weight, and power, we're always optimizing for the unoptimizable combination of the best of the three, which, it's different when, of course there's size constraints to how big you can build your data center and how big of a nuclear plant you can build next to it, but it's different than trying to put something that can be powered, on a plane and with plane power and not allow the plane still to be able to take off after you put it on there. That kind of thing is important. Shock and vibe, most of these processors, even if you just had the chip and you could just power it without a board, can't even take the shock and the vibe within the package that is required, except for the ultra mobile parts, which aren't necessarily what we need in this industry, and I'll talk about that in a moment. Both hardware and software security. So we've talked a bit about that today, but you need both. And you have to think of, in our world, it's not so much as someone going to get over your Ethernet connection into your box. It's your data center just fell in the lap of someone of the adversary, and need to understand what they can do to get into your device and how they can reverse engineer it and things like that. And safety certifications. So a big thing, especially when people's lives, whether it's protecting our nation or otherwise, when artificial intelligence is making decisions, even if they're decisions that help a human make a decision, these applications are really hard to trace back and figure out how they decided what they did and trace it back like a black box, on a commercial airliner. You want to at least make sure that your hardware is always doing what you think it's doing. So the safety certifications become important. So something Mercury works a lot on is trying to get the same kind of product you use in the data center into the embedded platform. And with artificial intelligence, that's become a big deal. All the new processors coming out have special cores and tensor cores and all special application-specific instruction sets that you can use. But they come in those, what you're seeing here is the Xeon D versus the big real Xeon processors with the E5 SP class. And they're a completely different processor. All those pins give you more I/O between boards, between processors, access to more memory, higher speed memories. And the little chip is what embedded is giving us from the vendors. So being able to figure out ways that you can put down the real processor, and kind of on the right-hand side, you see we actually ball those processors and put down the big honking chip and make it survivable in the airborne and other environments. So that's a real important part. We're working with the vendors trying to help supply, frankly, the nation with the equipment they need, but it's a struggle based on just the volumes we have and the life cycle that they have to support it. Technology of survival, so this is just everything else that goes around the processor, right? We need to do a lot more than the Facebooks, the Googles, the Intels, the NVIDIAs are doing in-house to try to figure out how these are going to survive, these processors and memories and entire products are going to survive out in the field. And you see a progression of different covers for that one board there. That's actually showing how, Mercury systems, we try to build affordable, as affordable as possible, these high processing boards by making them adaptable to many different types of cooling solutions, whether it's conduction cooled or air cooled. But that just illustrates the fact that there's so many different environments versus just a controlled data center where these products have to go. And that's another thing that, it's only companies like in this room that can understand and figure that out to be able to make it run an artificial intelligence application. So security, different kind of adversary. Like I said, the data center can fall in someone's lap. So everybody already kind of explained for me the anti-tamper and all the reasons why this is important. So I think that's, pretty clear. But, it's something that goes beyond just the physical hardware. It goes to where the hardware comes from. Mercury has manufacturing and multi-chip processing capabilities to build our own chips and things like that in the country. And so knowing where it comes from is obviously really important. And also for mission and control systems, really for everything, the safety certified aspect of things. So DO-178, DO-254, when we're depending on these applications to make decisions, we used to have relatively simple control devices that had to be safety certified because they were, you turned your joystick and that's the other end of it, the computer that was helping actually turn the actuator. But now you need a whole computer that is actually really capable, has those big processors on it, that has all the full capabilities of a data center computer to have that kind of safety certification capability because, now you need that really intense application to be really safe and always know that it's going to do what you want it to do. And it's not, I say safety is not peanut butter because you have to, it has to be built in from the start. And my colleague here, Scott Engel, is going to talk tomorrow, I believe, actually about both the security and the safety and how they play together, and he'll go into a little bit more detail around that. And trusted sourcing. So I started to mention, just down the road in Arizona, Mercury has a manufacturing facility where most of our products are manufactured. Most of the systems we build, like one I'll show here in a moment that's specific to artificial intelligence, contains mostly our components and boards to build a whole system to do these things. So it's all from one-stop shop. The people, you need to know who's working on your product at all times. If you're outsourcing capabilities, software development, hardware development, who's involved with that. And it's really something that in our country, being able to do all that in one place is a real challenge, and it's not something the commercial vendors usually worry quite as much about. It's something we're all finding ways that we can pull as much, into a safe environment as possible. Open standard architecture, so I wanted to mention this because, obviously we're here, VITA, and most of Mercury, the area I work in Mercury is the 6U, 3U Open VPX platforms. But that protects an artificial intelligence or other application system, not just from making it easier and more affordable to build it, but it protects it from long-term life cycle. What if Mercury's not here? What if anyone else is in the room isn't here anymore? How do we make sure that that asset is able to continue its life? And that picture is actually, it's a little old now, but it's when we were doing the VITA 4611 system management testing, and we had a bit of a plug and play with all the vendors to show that you could keep a system monitored, managed, and running with multiple vendors in the same box. So I'll leave you just with, I'm kind of just talking at a high level about trends and what do we do that pertains to artificial intelligence. This is something you've probably seen, a commercial example of an artificial intelligence processor, the NVIDIA DGX box with their HGX architecture. They have different flavors and sizes of it. I think they have much bigger pictures now with like 16 GPUs. But it's essentially a dual processor, Intel Xeon, the data center class Xeon, with PCIe fabrics connecting many GPUs to that infrastructure, allowing you to deploy like TensorFlow algorithms across that whole thing. So like the NVIDIA, the artificial intelligence software talk we talked about earlier, really lends itself and is actually targeting this because this is what's in the data center running most of Google and Facebook and other people's artificial intelligence algorithms. So what Mercury is building is we can build you the same box with the same essential architecture. We have all in-house with our own components. We have Mercury processors with the dual Xeon real data center class processors. We have PCIe switch fabrics modules, and then GPU modules with the NVIDIA graphics cards, and we're building security and safety into all of this. So you can essentially bridge that gap from commercial application into an embedded environment that needs all those security and safety aspects, and get nearly one-to-one performance profiles between the two, and not need to re-architect your code as significantly. So going back to the beginning when Elon Musk was, Elon Musk has figured it out now. Einstein couldn't see what the future was, but apparently Elon does. But I think whether it's AI or not, I think we see that there's potential shifts in what defines being a power in military and defense and aerospace. And this is one potential thing, but I think no matter what the application is, all these aspects of security, trusted manufacturing, safety, and so on, and open standards are going to be really important. So that's all I have. Happy to talk to you about any of your application needs. We're seeing a lot of artificial intelligence interest in building these kinds of systems, so we're happy to help wherever we can. Thank you.